Hi, welcome to Introduction to Physics on your online component. This video is to review skills that you need going into physics. The first 4 slides are what we talked about in class, but they are here for your review if you need them. So that's just the goals of our course, the essential questions that we discussed, and the class expectations, and of course the flipped classroom expectations. If you have any questions, feel free anytime or come up to me in class. Reviewing skills you need into physics. These significant scientific and precision is accuracy. So the first 4 bullet points should be things that you are very familiar with. You have done them in other classes. If you are not, you're going to struggle in this class, so come talk to me. But I'm sure that you've done them before. So let's talk about SI units. I just have a few charts in here to kind of help you. They are also on the cheat sheet that is posted online. I guess it's called the toolkit online. But it just has the different names and symbols of the SI units. A lot of them should look familiar. If they don't, we will talk about them later. Unit conversions, these need to be memorized. You need to know how to go from femto to kilo or centi to deca off the top of your head. Most of the time it's easiest if you memorize them to the base, and then you can go from one to the next. This should be really familiar if you have questions. This one is derived from physics. So a lot of them we're going to use. This is kind of a glance at what we're going to be using this semester. We'll talk about each one as it comes along. This is another chart. So this is really the bulk of where we need to be. So dimensional analysis is something that you need to be able to do right off the bat. You've done this probably in several classes, and it's going to be really important for your physics skills. But we'll go through it just as a reminder since you are back from summer. So, of course, dimensional analysis is just converting from one unit to another. So from miles per hour to kilometers per hour. Or we'll look at some examples. There will also be some on your worksheet tonight. So the first thing is your setup. If you look at these, I call these the railroad ties. Of course, your railroad ties you don't have a set value. You're going to have as many or as little as you need per problem basis. But the general setup is you write your starting units at the beginning and your ending units at the end. You then look at your unit conversions that you need for the problem and go through the math. Let's look at an example. So let's convert 35 miles per hour to meters per second. So I start by writing down my starting units, that's miles per hour, and my ending units we want is meters per second. So 35 miles per 1 hour. That's hidden in the problem. Per always means something's going to go on the bottom. Then I go through and I put on my ending units, meters per second. And I go through and I say, okay, I know I'm converting a distance to a distance, so let's look at that. We need miles to meters. 1 mile equals 1,609 meters. And then I'm also converting time, so I need hour to seconds. So 1 hour is 60 minutes, 1 minute is 60 seconds. So I just fill these in. 1,600 meters per mile. So we always are mental. So if we have miles, I need miles on the top now. Bottom, so we need minutes on bottom. So you go through and I always cancel first track without side. Make sure you're using proper parentheses. So I would do 35 times 1,609 and 0.6 meters. If you need more example video on YouTube that is posted under our lesson 1 unit lesson. So significant figures is another thing that a lot of teachers are very about.